is equal to h by p. Cosec theta is h by p. Cos theta is b by h, so sec theta is h by b. And tan theta is p by b, therefore cot theta is b by p. These are the 6 trigonometrical ratios which are formed. Sin theta is p by h, cos theta is b by h, tan theta is p by b, and the reciprocals of these, cosec theta as h by p, sec theta as h by b, and cot theta as b by p. These are the 6 trigonometrical ratios, and you are to memorize this part before we start the exercise. While solving numericals on a right angle triangle in trigonometry, another point to be noted is, if this is the perpendicular side, this is the base and this is the hypotenuse, we will be widely using the Pythagoras theorem. We will be widely using the Pythagoras theorem. And what does it state? It states that p square plus b square is equal to h square. Therefore, if any one of the side is not given, suppose we have to find p is not given. So p square will be equal to h square minus b square, or p will be equal to square root of h square minus b square. Alright, so this is how we find the perpendicular side, base, and for hypotenuse simply square root of p square plus b square. So we will be widely making use of this one and the 6 trigonometrical ratios which we have done. With this, let us start the first exercise, Selena, exercise 22a. Question number 1. Introductory part. Let us understand what the 6 trigonometrical ratios are. There is a right angle triangle given, and in this right angle triangle the two sides are 3, 4, and the triangle is right angled at B. This is A and this is C. From this we have to find the values of sin A, cos A, third is cot A, fourth is sec C, fifth is cosec C, and sixth is tan C. For all these things, because we are given two sides of the triangle, we have to find the third side. To find the third side, that is to find AC, applying Pythagoras theorem, AC will be equal to what? Square root of, I am writing it directly, 3 square plus 4 square, which is 9 plus 16, or square root of 25, which is equal to 5. Once we get AC as 5, we will proceed this way now. Sin A will be equal to perpendicular by hypotenuse. Therefore, 3 for sin A. Sin A, 4 is perpendicular side and 5 is the hypotenuse. Alright, for this angle A here, for the angle A, 4 is the perpendicular side and 5 is the hypotenuse. So sin A is equal to 4 by 5. Similarly, cos A now, formula is base by hypotenuse, and this will be equal to, for cos of this angle, 3 by 5. Cot A will be equal to base by perpendicular. So this has to be learnt. Alright, these ratios has to be learnt before we start with the exercise. Cot A is equal to base by perpendicular. For this angle, base is 3. 3 by 4. Then sec of angle C. Sec of angle C. Sec is the ratio of hypotenuse by base. Hypotenuse by base. And for C, hypotenuse is 5, base is 4. Hence the ratio will be 5 by 4. Then we have cosec C. Cosec of the angle here. Cosec is equal to hypotenuse by perpendicular. It is the reciprocal of sine. Therefore, 5 by perpendicular. Perpendicular will be, for this angle, perpendicular side is 3. So 5 by 3. Next is tan C. Tan C will be perpendicular by base. And the perpendicular side for C is 3 and base is 4. So this is how we find the trigonometrical ratios with respect to angle A, with respect to angle C. Let me take up one more question of the same exercise 22A. Question number 3. This is the figure. A, B, and this is named as C. This is a right angle here. Length of this one, this side is 3, 4, 12. From the following figure, find the values of the first one, cos A. Second, cosec A. Third, tan square A minus sec square A. Fourth, sin C. Fifth, sec C. Sixth, cot square C minus 1 by sin square C. Now the first one, cos A. For this triangle, let me take this point as, it's not mentioned in the question, let me take this point as D. For triangle ABD, by Pythagoras theorem, AB will be equal to what? AB will be equal to square root of 4 square plus 3 square. Once again, this is 16 plus 9, 25. And square root of 25 is 5. Therefore, I'll take this as 5 here. The first one, cos A. Cos of the angle here will be equal to base by hypotenuse. So, I am not writing the ratio now. I have already written that in detail in the first question. Cos A will be equal to 3 by 5. We are doing it directly. Cosec A. Cosec of this angle. Now, cosec will be equal to hypotenuse by perpendicular. hypotenuse by perpendicular. That is 5 by, for this angle 4 is the perpendicular side. Next, tan square A minus sec square A. First let us find out what is tan A. Tan A is equal to 4 by 3. So 4 by 3 whole square minus sec A will be equal to 5 by 3, right? Hypotenuse by base. 5 by 3 whole square. This is equal to, I'll do it here, 16 by 9 minus 25 by 9, which is equal to 16 minus, since we have 9 in the denominator, 16 minus 25 is minus 9 by 9, which is equal to minus 1. So tan square A minus sec square A is minus 1. Now we come to the second triangle here, this BDC, in which again using Pythagoras theorem, DC will be equal to square root of 12 square minus 4 square, which is 144 minus 16, which is equal to 128, right? Square root. This is equal to root of 128. Root of 128, if you factorize, it will be equal to 2 to the power 7 under root, which is equal to 8 root 2. Right? 2 to the power 7. So 2 to the power 7 under the square root sign, which will be equal to 8 root 2. So sine of angle C, sine of angle C will be equal to 4 by 12. 4 by 12, which is equal to 1 by 3 on cancellation. Sec of angle C, sec will be equal to hypotenuse by base for this angle. So 12 by, this will be 12 by 8 root 2. This will be, if you cancel, 2 times, 3 times. 3 by 2 root 2. And because we have root 2 in the denominator, multiplying it by root 2 in the numerator and root 2 in the denominator, it becomes 3, 2 into 2 will be 4. So this will be equal to 3 root 2 in the numerator, and root 2 into root 2 is 2 into 2, 4. 3 by 4 root 2. You can also leave this answer here. This will also be correct answer. 3 by 2 root 2. Alright. The last one, sixth one, cot square C minus 1 by sine square C. So let me, for this, rub out these parts. Alright, cot square C minus 1 by sine square C. Sixth one, cot square C. Cot will be equal to base by perpendicular. So 8 root 2 by 4 whole square minus 1 by sine square C can be written as, alright, I'll write sine C here. So sine C is 4 by 12 and square of this. Therefore this becomes, this is 1 by 3. This cancels. 2 root 2 whole square is, 2 square is 4 into root 2 into root 2 will be 2 minus, this is 1 by 3 whole square or 1 by 9. So 9 will go to the numerator and 1 will remain in the denominator. This is 8 minus 9, which is equal to minus 1. Alright. So these are a few numericals which I have done. On the basis of this, try to solve a few sums from exercise 22A, such as question number 4, 6, 4 and 6. Try solving for homework. Write down these in your notebook and then try solving question number exercise 22A, question number 4 and 6. Alright. Thank you, children.